Hello everyone. In this tutorial video, we are going to learn about cams. Cams is something what you will find in many of the automobile components where you want the reciprocating motion to be converted into rotary motion or the vice versa. So these cams will be found in automobiles where the IC engine's inlet valve and outlet valve will be controlled by this cam profile. The duration to which the inlet valve has to be opened, the duration to which outlet valve has to be opened, and the duration to which both the valves has to be closed is all decided by the profile of the cam what you see in this picture. So these are some examples the application of cams. So in this video you will learn the introductory concepts about cams, what are the different types of cams and followers, and what will be the different types of motions that can be achieved from cams. All these things will be discussed in this video.
And this is Alvin presenting you.
What do you mean by a cam? Cams are used to convert the rotary motion into reciprocating motion. So any rotary motion which we obtain from a shaft can be converted to a reciprocating motion, reciprocating in the sense linear motion. And the vice versa can also be applied, which means that any reciprocating motion can also be converted into rotary motion. As I already mentioned, the example is IC engines. So this cams is one of the part which is majorly used in internal combustion engines. So this is a cam profile. What you will see here, the rotary motion of the cam is converted into the reciprocating motion of this particular link what you see, which is moving in the vertical direction. This vertical link is called as the follower. And this is another example which is simply the animation of an IC engine, and the piston is moving in reciprocating motion while the inlet and outlet valves are opening and closed here, this blue color, which is controlled by the cam what you find at the bottom part here, which is in dark green color. Next we will look into the classification of cam mechanism. Now the cam mechanisms can be classified based on the input and the output motion. The major components of a cam will be a cam itself and a follower which comes along with it. And based on the input given to the cam and the output motion obtained from a follower, we can classify the cam mechanism as we see here. The first one, rotating cam and a translating follower. So you can see this is an example of a rotating cam and a translating follower. We see that the cam is continuously rotating while the follower is having a translating motion. The translating means linear motion. The next type of cam mechanism we will find is a rotating cam and oscillating follower. As we saw that the follower is having a translating motion in the first type, in the second type we will see that the follower will have an oscillating motion. So you see here this part which is rotating continuously is the cam, and the one which is moving up and down in this direction is nothing but the follower. Now this motion of follower is going to trace a oscillating motion. So hence we call this type of cam mechanism as rotating cam and oscillating follower. The third one is translating cam and translating follower, which means that both the cam as well as the follower will have a linear motion. So we see this is the cam profile what is found here. This is also going to move in linear direction while the follower will. Next we will have the classification of followers. So that based on the shape of the follower we can classify the followers as we see here one by one. The first type is called as knife edge follower, and you can see in this sketch the follower is having the tip in the form of a knife edge. This is the tip of the follower which is in contact with the cam, which will be in the shape of a knife edge, which means it is a sharp edge. So this type of followers will be called as knife edge follower. The second one is called as flat face follower. So the shape of the follower at the tip which is in contact with the cam will be in the shape of a flat face. So here you can see a two-dimensional view of the flat face follower, and we see that the tip of the follower is simply a flat face. It might be a circular one or a rectangle or a square, it doesn't matter, but the part which is in contact with the cam will be a flat face. It is called as flat face follower. And the third one is called as roller follower, where the follower tip will be in the form of a roller. So here we see the cam is continuously rotating while the follower which is in contact with the cam is in the shape of a roller. This type of follower will be called as roller follower. And the next one is called spherical face follower, and here we have the part of the follower which is in contact with the cam in the shape of a sphere. So this is a half spherical shape what you'll find here, and here we are not concerned about which type of motion the follower is having, whether oscillating or translating, it doesn't matter. We are concerned about the type of follower, that is the shape of the follower, which is going to be in the form of a sphere. So this is an example of a spherical face follower. These are the four types of followers which we will get depending on the shape of the follower. We can also classify the follower depending on the path of motion of the follower. This is another way of classifying the followers. The first type is called radial follower. The radial follower simply means that when the motion of the follower is along an axis passing through the center of cam, it is known as radial follower. Irrespective of the shape, whether it is knife edge, roller, flat face or spherical, irrespective of the shape of the follower, if the axis of movement of that follower passes through the center of cam, then we can call it as radial follower. You can see in all these four examples, in all of them, the line of movement of the follower is aligned with the center of cam. And you can see here also, this is a line of motion of the follower and it aligns with the center of cam. And same thing goes with the spherical follower. This is called as radial follower if this line of motion of the follower aligns with the center of cam. And the second type is called offset follower. Offset follower, as the name implies, the line of motion of the follower will be offsetted from the center of cam. And as you see in these four examples, the first one is knife edge follower, but the line of motion of the follower is offsetted from the center of cam. Now it is not required that it has to be offsetted in the right direction, it can be offsetted even in the left direction. But in these sketches we see all the four types of followers are offsetted towards the right side. And this is called as the offset follower. Now let us come to the classification of cams itself. So we saw the classification of followers and we saw the classification of cam mechanisms. And now we are seeing the classification of cams itself. The cams can be classified as radial or disc cam. So this is a common type of cams what you will find in many applications. So in radial or disc cam, as you see here, the follower will reciprocate or oscillate in a direction perpendicular to the cam axis. So if you see, this is the center of cam and the cam axis is in horizontal direction, we see that the follower is moving in vertical direction. And this type of motion will be called as the radial or disc cam. The second type is called cylindrical cam, where the cylindrical surface of any object will be grooved. There will be a grooved slot which will be created within which the cam will be attached, whether it might be roller or it might be a spherical or it might be a another cylindrical part which will be attached into this groove. As and when the cylindrical part is rotated, we'll see there is some oscillating motion obtained for this follower. So cylindrical cams, the follower reciprocates or oscillates in a direction parallel to the cam axis. So we see here in this example, the follower will oscillate in this direction, which is the front plane, and we see that the axis of the cylinder is also in the front plane. So the motion of the follower and the axis of the cam are parallel to each other. If it is perpendicular, then it is called radial cam. If it is parallel, then it is called cylindrical cam. And the third type is called end cam. End cam is actually similar to the cylindrical cam, but the follower makes in contact at the periphery of the cam. So this is the topmost periphery of the cam what we find in this example, and the follower will be in contact with the cam at its periphery. But what happens in cylindrical cam, it is not in contact at the periphery, but it is in contact with the cam somewhere in between the surface itself where the groove has been created. That is the difference between cylindrical cam and end cam. And the major difference here between these three cams is that the follower will reciprocate in perpendicular direction in radial cam, while it is going to reciprocate or oscillate in a direction parallel to the cam axis in both cylindrical and end cam. Next, we will discuss about the cam nomenclature. So there are certain terms that comes into picture whenever we are designing or drawing a cam profile. And we will see some of the common terms of which we need the knowledge in order to understand the constructional process of designing and drawing a cam profile. So the first thing is the cam profile itself. The cam profile is the contour of the working surface of the cam. So there is a working surface in the cam as we saw in the previous slide, and the next one is called as base circle. The base circle is very useful whenever we are designing and constructing the cam profile. This is simply the circle that is drawn tangential to the cam profile with its center on the axis of camshaft. So this will be the center of or the axis of the camshaft, and we see in this diagram the cam profile is mentioned with the help of this dark line, dark hatched line. And the circle drawn which is tangential to this cam profile is called as the base circle, as you see in this particular diagram. Next is called as trace point. It is a point at the knife edge follower or the center of a roller or a center of a spherical face. So it is a point which is found in the center of roller if it is a roller follower, and it is a tip of the knife edge follower, or if it is a spherical face follower, then the center of the spherical face will be called as the trace point. So you see here this center will be called as the trace point. Next one is called pitch curve. The path generated by the trace point is called as pitch curve. So as you see here, for this particular cam profile in this example, the path traced by this trace point is called as the pitch curve, as it is named here. Right? So for this cam profile, when the follower is tracing a point from its trace point, we will get this particular outer curve. This outer curve is called as the pitch curve. Next is called as the prime circle. The smallest circle drawn tangential to the pitch curve with its center as axis of the camshaft, that is called as prime circle. Like we drew the base circle, in the same manner we are going to generate the prime circle. Base circle is something which is drawn tangential to the cam profile, while prime circle is something which is drawn tangential to the pitch curve. So pitch curve is the outer one what you see here, and when a circle is drawn tangential to this, as you see in this diagram, that circle is called as the prime circle. Next one is called as a pressure angle. Pressure angle is the angle between the direction of the follower movement and the normal to the pitch curve at the point of contact. Suppose if this is the point of contact of the follower, then you just draw a normal line or a line which is perpendicular to the pitch curve. So this is a pitch curve what we have, and when a perpendicular line is drawn to it, this is the position of the follower, there will be some angle developed. That angle is called as the pressure angle. Next is pitch point. Pitch point corresponds to the point of maximum pressure angle. So like the position of follower, at every point in that cam profile, we will find different pressure angles throughout the contour of that cam profile. So at some points we will have the pressure angle maximum. Those points will be called as the pitch point. Stroke or lift. It is a maximum travel of the follower from the lowest position to the topmost position, or angle through which the follower moves or rotates. Now you see there is a follower which is moving in translating direction or linear direction. So this follower will be at lowest position, and at some point in the cam profile this will reach to the maximum height, that is the topmost position. So the distance from the lowest to the topmost point is called as the stroke or lift. Similar to what you will find in the internal combustion engines, the movement of piston from bottom dead center to top dead center will be called as stroke. In the same manner, here we do not have dead centers, but here we call it as the lowest position to the highest position. And it is also measured in terms of angle if it is a oscillating follower. For a translating follower, we will measure it from lowest position to topmost position, and for an oscillating follower we'll measure it with respect to angle through which the follower moves or rotates. Next is called as the dwell. Dwell is simply the period during which the follower is at rest. And you saw in the previous animations and the pictures what we discussed in this previous slides, the follower will be in continuous motion during the operation of the cam. And at certain point of time, the follower will not have any motion during the rotation of the cam. That portion of period during which the follower is at rest, it is not moving in upward direction. That period of time is called as the dwell period. The motion of follower. As the cam rotates, the follower moves upward and downward. When the follower is moving upward, we call it as rise, or it is also called as the outstroke. The downward movement is also there for the follower. As we see, the follower will have two different motions. One is upward and other is downward. The downward movement is called as fall, or it is also called as return stroke. So in solving problems and all, you might find the data given with respect to rise and fall, or in some problems you'll find it with respect to outstroke and return stroke. So you must know what is the meaning of rise and fall. Rise means the upward movement and fall means the downward movement, and same applies with outward stroke and return stroke. When the follower is not moving upward or downward, we discussed this in the previous slide, even when the cam rotates, the cam will be rotating but the movement of follower will not happen. That period of time is called as the dwell. These are the three terms which you need to remember with respect to the motion of follower. The types of follower motion. You will find the follower motion with different types of motion. You will find it with uniform motion, that is called constant velocity, or you will find the motion in the form of simple harmonic motion, or you will find it like uniform acceleration and retardation motion, which is called as UARM, or you will also find it with respect to cycloidal motion. So depending on the problem and the data and the given profile and the working conditions, the follower will have any of these type of motions, and it completely depends on the type of follower, the given data and the application and the design of that cam for which it is actually proposed. Based on that, it will have any one of this type of four motions, and depending on any one of these four motions we will have different methods to solve the problem. If the follower is having a uniform motion, the way in which we design the cam profile will be a different one. Same applies with SHM. If it is SHM, then the method that we need to use to develop the cam profile or design the cam profile is different. Depending on the motion, the method will also change, which you will have a better idea when we start solving the problem and look at examples where the follower will have any one of these four motions for every duration of outstroke, return stroke, dwell period and other things. So we'll look into all these types of four motions in a much more detailed way once we take up an example and solve it. And that completes the introduction to the cams. So having these knowledge and the terms which we discussed till now in this video, you will have a better idea when we start solving the examples, because without understanding and knowing these terms, it is very difficult to understand the example. For any doubts or clarifications, you can drop a comment or contact me through my mail ID.